Section 6.5 Series and Parallel Inductors. If we connect n inductance in series, how can we get the equivalent inductance? And we can do it like this. Because they are in series, so we can use KVL and we get V equals V1 plus V2 plus V3 and so on until Vn. And then we replace V1 to Vn with the current I. Because they are in series, so the current through them are the same. And finally we get the equivalent inductance Leq equals L1 plus L2 plus L3 and so on until Ln. So the equivalent inductance of series connected inductors is the sum of the individual inductances. And now, how about the parallel connection? If we connect n inductors in parallel, how can we get the equivalent inductance? Because they are in parallel, so we can use KCL and we can get this equation I equals I1 plus I2 plus I3 and so on until In. And then we replace the current with the voltage. Because they are in parallel, so the voltage across them are the same. And finally we get the relationship between Leq and the L1 to Ln. The reciprocal of Leq equals the reciprocal of L1 plus reciprocal of L2 plus so on until the reciprocal of Ln. For two inductors in parallel, and we can get a simple equation Leq equals L1 multiplied by L2 over L1 plus L2. And the equivalent inductance of parallel inductors is the reciprocal of the sum of the reciprocals of the individual inductances. Now we put all the important relationship and properties of the basic three elements resistor, capacitor, and inductor into this table. And you can check it when you need it. For example, you can check the relation between V and I for all the three elements, and you can find the power or the energy for all the elements in it. For example, the energy stored in a capacitor W equals 1 over 2 multiplied by C multiplied by V squared. And then you can find the equation about the equivalent resistance or equivalent capacitance or equivalent inductance when they are in series and in parallel. And you can find the property of it for DC. For example, the capacitor is open circuit for DC and the inductor is short circuit for DC. And you can find which variable cannot be changed abruptly. For example, the voltage cannot change abruptly. But for the inductor, the current cannot change abruptly. This is the end of this section.